In this video, we have an indefinite and a definite integral to evaluate. Now, if I look at the denominator here, I got x to the third plus 16 taken to the second power, and you can see the derivative of x to the third plus 16 is 3x squared. The most important thing here is that I get an x squared, and I got an x squared in the numerator. The constants can always be factored out, so no issue there. So this tells me that this should work out with a U-substitution. So I'm going to let U equal x to the third plus 16. Take derivatives here with respect to U on the left. Get du with respect to x on the right. So I get a 3x squared. Derivative of constant 16 is 0. This gives me the dx. I divide through by 3 here. This cancels out, and that tells me that the x squared dx can be replaced by du over 3. And of course, the x to the third plus 16 will be u. And then this will be the x squared dx is going to be du over 3. But I can divide 3 into the 12. That'll give me a 4. Got a du here. And then this is u, so this will be u squared. Now we transform the integral into one involving u. So we're ready to integrate with respect to u. One more thing though, I'll take this to the top here, to the numerator, it becomes a u to the negative 2. Still have a 4 here. This is du. And then integrating with respect to u here, we add a 1 to the minus 2, we get a negative 1. So the u to the negative 1. And of course the procedure is to divide the coefficient by that, so this will be a minus 4 here. And then it's plus the constant of integration. Then no matter what substitution you use, you always have to go back to the original variable, and that is an x. So this will be a minus 4. And then the u is x to the third plus 16, so I could put x to the third plus 16 here as a factor to the negative 1 power, but if I take it to the denominator, just another way to write it. So I write it as minus 4 over x to the third plus 16. And that's plus the constant of integration. So that's the answer for this one. Now the next one, I have the integral, definite integral here from 0 to pi squared over 4 sine of the square root of theta over the square root of theta d theta. The square root of theta, if I take the derivative of that, that'll give me a 1/2 theta to the negative 1/2 power. So you look at this, I let u equal to the square root of theta. Then du is just theta to the 1/2, okay? Divided with respect to theta, the 1/2 comes out front. And then I subtract 1 from the 1/2 power there, and I get theta to the negative 1/2. That's du. Another way to write this, I multiply by 2 here. Both sides by 2. I get 2 du. Let me rewrite this. Theta to the negative 1/2 goes to the denominator. And I can write that, instead of the 1/2 power, I can just write it as the square root of theta. Remember, the objective now is to convert this to a variable, to the variable u. This is going to equal 2. Notice right here, d theta over the square root of theta, that's 2 du. So I can write this as 2. And this is replaced by du, and the sine of the square root of theta, well, square root of theta is sine of u then. got the square root of theta, and that's u. So I get this. And the d theta over the square root of theta becomes a 2 du. There's my du. I got the 2 over here. Now I'm dealing with the variable u, and remember the original limits here of integration involve theta. So let's go 0. I put a 0 there. When theta equals to 0, u equal to the square root of 0, that's still going to be 0, so this is not going to change. This will be 0 here. And when theta equals pi squared over 4, u will be the square root of that. The square root of pi squared is pi, and the square root of 4 is 2. So this becomes a pi over 2. Now we're set. We have everything in terms of u. The limits now are in terms of u. So first let's take the integral of sine u. The integral of sine u is a minus cosine. Still got the 2 there. So it's minus 2 here. So the integral of 2 sine u with respect to u is minus 2 cosine u. And then we evaluate from 0 to pi over 2. So remember, we evaluate this value right here, the integral, at pi over 2. So that's minus 2 cosine pi over 2. And then it's minus the value of this expression here at 0. So this will be minus 2 cosine of 0. Now the cosine of pi over 2 is 0. Multiplied by negative 2, that's still going to be 0. That goes to 0. The cosine of 0, and here we're dealing with radians, but it's the same thing as actual 0. The cosine of 0 is 1. 1 times the negative 2 is negative 2, but then we have the minus here, so we get 2. So the value of the definite integral is 2. Thanks for watching. We'll see you next time.